4684-3. How does BARO-VNAV provide vertical guidance during an RNAV approach? A. GPS-equipped airplanes use the existing ILS glide slope signal for vertical guidance during BARO-VNAV approaches. B. By defined vertical angles or altitudes as fixes using the local altimeter setting. C. Using a series of step-down fixes. The correct answer is B. BARO-VNAV, barometric vertical navigation, provides vertical guidance during RNAV, area navigation, approaches by using defined vertical angles or altitudes as fixes. These fixes are typically specified in the approach charts and are based on the local altimeter setting. Pilots reference these vertical angles or altitudes to maintain the desired descent path during the approach. The local altimeter setting ensures that the altitude indications are accurate relative to the local atmospheric pressure conditions. For 4684-5, your avionics system offers advisory VNAV functions, but does not use WAAS or BARO-VNAV systems. Which statement is true? A. You may use your avionics system to execute approaches to LNAV/VNAV minimums. B. Your avionics system cannot be used to execute approaches to LNAV/VNAV minimums. C. You may use your avionics system to execute approaches to LNAV/VNAV and LPV minimums. The correct answer is B. If your avionics system does not use WAAS, Wide Area Augmentation System, or BARO-VNAV, barometric vertical navigation systems, it is not capable of providing the necessary guidance and accuracy required for LNAV/VNAV, lateral navigation/vertical navigation approaches. LNAV/VNAV approaches require both lateral and vertical guidance, which typically rely on satellite-based augmentation systems like WAAS or barometric systems like BARO-VNAV. Without these capabilities, your avionics system is not authorized for executing LNAV/VNAV approaches. 4702. What is the difference between an SDF and an LDA facility? A. The SDF course width is either 6 degrees or 12 degrees, while the LDA course width is approximately 5 degrees. B. The SDF course has no glide slope guidance, while the LDA does. C. The SDF has no marker beacons, while the LDA has at least an OM. The correct answer is A. An LDA is of comparable utility and precision to a localizer, but isn't portion of a total ILS. The LDA more often than not gives a more exact approach course than the SDF, which may have a course width of 6 degrees or 12 degrees. The LDA course widths are from 3 degrees to 6 degrees. 4073. What is the difference between a localizer-type directional aid, LDA, and the ILS localizer? A. The LDA is not aligned with the runway. B. The LDA uses a course width of 6 degrees or 12 degrees, while an ILS uses only 5 degrees. C. The LDA signal is generated from a VOR-type facility and has no glide slope. The correct answer is C. An LDA is of comparable utility and precision to a localizer, but isn't portion of a total ILS. The LDA more often than not gives a more exact approach course than the SDF, which may have a course width of 6 degrees or 12 degrees. The LDA isn't adjusted with the runway. 4704. How wide is an SDF course? A. Either 3 degrees or 6 degrees. B. Either 6 degrees or 12 degrees. C. Varies from 5 degrees to 10 degrees. The correct answer is B. An SDF Simplified directional facility. Course width can be either 6 degrees or 12 degrees. The course width refers to the angular extent of the usable signal emitted by the SDF facility. The wider course width of 12 degrees provides a larger area for aircraft to track and maintain course alignment. This flexibility allows for different operational requirements and airspace configurations. So, the SDF course can be either 6 degrees or 12 degrees in width.